Okay, so we are looking at multiplying and dividing rational expressions. So first, we're going to start with a warm-up question. Uh, so we have fractions here that doesn't involve any variables. Later on, we will look at the examples that involve uh, also variables. Okay, but the first one is only numbers. So we have 12 over 15 times 5 over 8 divided by 30 over 6. Before you simplify anything, you should get rid of the division. Okay, so 12 over 15 times 5 over 8. Now, when you're converting division to multiplication, so you just flip the fraction or you take the reciprocal of that fraction. So you get 60 over 30. Now you start simplifying the numbers. So you take one number from numerator and simplify it with a number that is in denominator. Okay, so let's say 5 and 15. Both of them are divisible by 5. So divide 5 by 5, you get 1. Divide 15 by 5, you get 3. Now let's say 6 and 30. Both of them are divisible by 6. So divide 6 by 6, you get 1. Divide
Miss
30
Jas,
by 6, you get 5. Yes.
sorry for interrupting, but so if I wanted to simplify the other way, could I do 5 and 30 and then 6 and 8, or is that not allowed?
Yes, yes, you could.
Oh, okay.
Okay,
So
any
what's a good
number.
way to do it? Is it good to go
The,
from right to left, or is there like,
there is no order. Just pick a
oh,
number from numerator and pick a number from denominator to simplify.
okay. I need to
Okay,
practice this probably.
yeah, it doesn't matter what order you use. Okay, so 12 and 8, both of them are divisible by 4. You get 3 and 2. And now you have 3 and 3. Divide both of them by 3, you get 1 and 1. So we have in numerator now 1 times 1 times 1, 1. And in denominator, 1 times 2 times 5 is 10. Okay. So like rational numbers, rational expressions can be multiplied or divided using the same rules. So this time we're going to do some examples again with variables. Okay. So when multiplying rational expressions, factor first, then apply multiplication of numerators and denominators separately. Last step is always state the restrictions. So when you are doing division or multiplication with the variables, then you have to check the denominator. And if anything makes the denominator 0, those are your restrictions, and you have to state those restrictions. So when dividing rational expressions, remember to multiply by the reciprocal of the divisor. So again, this is converting division into multiplication, right? That's what we do. So let's look at the examples. So the first one is multiplication. Okay, so we're going to start simplifying this. First, let's state the restrictions. Okay, so look at the denominators. So numbers 2 and 9 can never be 0. But if you take b square, okay, so can it be 0? Yes. If b is 0, then denominator becomes 0. So one of the restrictions, b cannot be 0. So now check this one. Can a square be 0? Yes. If a is 0, a square is 0. So a also cannot be 0. Again, if a is 0, denominator becomes 0, and you cannot divide any number by 0. Now we can start simplifying. We see, start from the numbers. We see 3 and 9. So both of them are divisible by 3. You get 1, you get 3. So now look at 2 and 10. Both of them are divisible by 2. You get 1 and 5. Okay, after you are done with numbers, now check the variables. So you have a cube and you have a square, right? Let's remember maybe some rules for uh, working with exponents. Let's say if you have a to the power of m over a to the power of n, how do you simplify this? If you have a division with the same base, okay, so you keep the base you subtract the powers. If you have multiplication, let's say you have a to the power of m times a to the power of n. So you keep the base, you add the exponents. So m plus n. So then if you have a cubed over a square, okay, so then you subtract the powers, you keep the base, subtract the powers, you get a. So first of all, numbers, I have 5 and 3. So a cubed divided by a square gives you a. Okay, now you have b cubed divided by b square. Again, subtract the powers. 3 minus 2 gives you 1. So b to the power of 1, which is b. Okay. Or you can just write 5 over 3ab. Doesn't matter. All right, so let's look at b. The first step is factoring. Okay, so x squared plus x minus 6. If we factor that, we get x plus 3, x minus 2, divided by, factor the denominator, x plus 5, x minus 3. Okay, so times x minus 3 over x minus 2. So before you simplify, state the restrictions. So look at the denominator. What makes them equal to 0? So we have 1, 2, 3 factors here. So x plus 5 becomes 0 if x is negative 5. X cannot be negative 5. X minus 3 becomes 0 if x is 3. So x cannot be 3 then. And x minus 2 becomes 0 when x is 2. So then x cannot be 2. Then start simplifying. So again, one factor from
Wait, Miss
numerator.
Taz, that like dot you put that represents multiplication, right?
Multiplication, yes.
Okay, all right.
All right. So x minus 2, again, one factor from numerator and one factor from denominator. So this is x minus 2, that is x minus 2, gone. X minus 3, gone. So you have x plus 3 over x plus 5, simplified with these restrictions. So let's look at C. We have 2ab over 5c divided by 14a squared b squared over 15c squared. So the first step, there's no factoring here, involved here, but you need to convert division to multiplication. 2ab over 5c times, you flip the fraction, you take the reciprocal. Which one you want me to do, Sandra? A. First, we look at the numbers and simplify the numbers. There is 3 and 9. Both of them are divisible by 3. So you divide 3 by 3, you get 1. You divide 9 by 3, you get 3. Then 2 and 10, both are divisible by 2. So you get 1 and you get 5. Okay, so 5 over 3. So 1 times 5 is 5. 1 times 3 is 3. Now you look at the variables. That is a cubed. That is a square. So then you simplify those. And I just showed how to do division. You keep the base, you subtract the powers. Okay, so 3 minus 2 gives you power of 1. So a to the power of 1. B cubed divided by b square. You keep the base, you subtract the powers. Is it okay? Okay. So let's go back to C. So again, we are converting this division to multiplication. We take the reciprocal, means we are just flipping that rational expression. So 14a squared b squared. Now, actually, we need to state restrictions. Okay, so you actually look at the restrictions before you get rid of the division and after. Okay, so before we get rid of the division, what do we have in denominator? We have 5c, so 5 cannot be 0, but c, if c is 0, denominator becomes 0. So c cannot be 0. So look at this, the other denominator, c square. Again, if c is 0, c square is 0, then denominator becomes 0. So c cannot be 0. After you flip it, you look at the denominator one more time. Okay, so this time, oh, this is this a or c? Can you check your handout, please? Is this c or a? Maybe you can type it in the chat.
It's C.
It is c. Okay, excellent. So then this one is c. Okay, so after we flip, what do we have here? We have a squared and b squared. How do they become 0? Or can they be ever 0? Yes, if a is 0, a squared is 0. So then a cannot be 0. If a is 0, again, you get 0 for the denominator here. And similarly, same thing with b. If b is 0, b squared is 0, then this denominator becomes 0. So b cannot be 0 as well. So when you are doing the division, you need to be careful. Before you flip, you look at the denominator. After you flip it, you again look at the new denominator. And then take the restrictions from there too. Now we can start simplifying. 5 and 15. Both are divisible by 5. So 5 divided by 5, 1. 15 divided by 5, 3. 2 and 14. Both are divisible by 2. So you get 2 divided by 2, 1. 14 divided by 2, 7. Okay. So what do we have? 1 times 3. 3. 1 times 7, 7. Let's look at the variables now. We have a square. So if both are divisible by a, right? So you divide a by a, you get 1. A squared by a, you get a. So in the denominator, we have a. You know, you can do it on the side if it is confusing.
Do you mind? Do you mind explaining to me like the simplifying like the exponents? Do you mind explaining that to me?
In general, if you have a division, you keep the base, you subtract the powers. If you have a to the power of 5 over a to the power of 2, then you get a to the power of 3.
Oh, that's it. Oh, okay.
Okay,
Right.
that's it. Or if
Thank
you have
you.
multiplication, let's say a to the power of 5 times a to the power of 3,
And it would be 8 to the power 8.
a to the power of 8, you add it.
Okay, thank you.
You're welcome. Okay, and then here we said we have a in numerator and a squared in the denominator. So when you simplify this, you get 1 over a. Okay, so therefore I have a in the denominator here. So now simplify b and b divided by b squared, right? So you have b in the numerator, b squared in the denominator, b and b squared. So when you simplify these, you get 1 over b. Okay, now c's. So you have c squared in the numerator, c in the denominator, c squared over c. So divide both by c, you get c over 1 or c. So c in the numerator. Okay, so this is a simplified version of this operation with these restrictions here. Let's look at D. So we have a division. We can get rid of the division first and then the factor, or we can do it at the same time. Yeah, let's factor first and then convert the division to multiplication, okay? If you factor x squared minus x minus 20, you get x minus 5, x plus 4. If you factor x squared minus 6x, factor x, you get x minus 6. Okay, divided by, now factor this, x squared plus 9, x plus 20, x plus 4, x plus 5 over. So this one, so that's a perfect square trinomial. We looked at those kind of factoring before. This gives you x minus 6 square. Okay, now let's state the restrictions before we get rid of the division, and then we are going to add some more if necessary after we get rid of the division. Okay, so again, the first, without getting rid of the division, so x cannot be 0, right? If x is 0, this denominator becomes 0, so x cannot be 0. X cannot be 6. Again, if x is 6, then this becomes 0. And this is also x minus 6 squared. So if x is 6, this becomes 0. Okay. So now, next step, keep the factors as they are. So flip the second rational expression. So x minus 6 squared over x plus 4, x plus 5. Now, add the new restrictions. Okay, we already covered this part. Now we need to look at this denominator. X cannot be negative 4, and x cannot be negative 5. Now start simplifying. X minus 5, x plus 5. So we can't simplify that. X plus 4 is gone. And we have x minus 6 squared over x minus 6. So if you divide both of them by x minus 6, so you get rid of this one, and then that square is gone. All right. So we have x minus 5. We have x minus 6 over x and x plus 5. Any question about this?
Miss Taz, isn't the x minus 5 and the x plus 5 opposites?
They are not opposites.
Yeah, I think they are.
If it was negative x, negative 5, so to have opposites, both of them have to switch sign. Okay, yes, this is positive 5, that is negative 5, but see, this is x, this is still x. All right, but if it was negative x, negative 5, so both, to have opposites, both of them have to switch sign. Okay.
Okay.
Yeah, so we looked at this example before. Let's say 5 minus t and t minus 5 are opposite, but see, this was negative t, positive t. Positive 5, negative 5. So if both of them switches sign, then they're opposites. All right, so that was positive x. Okay, so let's look at next example. Simplify and state any restrictions. We have a division. But again, before getting rid of the division, first let's factor everything. So 2 is a common factor here. X plus 1 over. Now factor this denominator. This is a perfect square trinomial. The first term is a perfect square and last term is a perfect square. And the middle term, as you see, 2 times first times this, the last term, so 2x. So then this is x plus 1 square divided by 4x is a common factor. So you get x plus 2 over. Now factor x squared plus 3x plus 2, x plus 1, x plus 2. So state the restrictions. X cannot be, look at this denominator. X cannot be negative 1. X cannot be negative 1, and X cannot be negative 2. Okay, and now we flip the fraction and convert division to multiplication. So x plus 1, x plus 2 over, so let me use dot here so that you don't confuse it with x. 4x times x plus 2. Now check the denominator one more time after you flip it. So x cannot be 0. X cannot be negative 2. You already have it there. Okay, so restrictions are done. Start simplifying. X plus 1, x plus 1 square, so square is gone. There is another x plus 1 though, so therefore both of them are gone. We have x plus 2 gone. We also have 2 and 4. Both of them are divisible by 2. So we have 1 left and nothing else. So 1 over 2. This is gone and only x left here. So 1 over 2x. Okay, let's look at B. So we're going to factor first. So we have x to the power of 4 minus 1. So that is difference of squares. We looked at that kind of questions before. X to the power of 4 can be written as x square square, and 1 is 1 square. Then you have difference of squares here. So you factor it as x square minus 1, x square plus 1, divided by, actually, you can factor this further. X square minus 1 is again difference of squares. So factor it right away as well. So that gives you x minus 1, x plus 1. Okay. So let me do it right away. X minus 1, x plus 1. Denominator looks like 2 is a common factor. We get x squared minus 4x plus 3 times. So we're going to factor this as well, but let's go ahead and do the others. So 4x is a common factor. It gives you x minus 3. 3 is a common factor. X squared plus 1. Okay. Now factor this one. So x squared minus 4x plus 3. Okay. So if you factor that, so you get x minus 3.
Wait, Miss Taz, I have a question.
Yeah.
So on you wrote x minus 1 and then x plus 1 and then x squared plus 1. Couldn't you just like, instead of writing x squared plus 1, couldn't you just have written like x squared and the first two brackets? Like like you see where x minus 1 x
Plus 1, yeah.
yeah, couldn't you
Because it was originally x squared minus 1, right? It was x squared minus 1. And that was another difference of squares. Maybe I should take another line and do it. Okay.
Oh, yeah. Do you mind taking another line?
Yeah, sure.
Thank you.
First, this is difference of squares because x squared minus 1 square. So you do x squared minus 1, x squared plus 1. So that is the first step. Okay, so I'll take one more line. So now I will factor x squared minus 1. That gives you x minus 1, x plus 1, x squared plus 1, because you have to factor as much as you can. Okay, now factor x squared minus 4x plus 3, x minus 3, x minus 1 times 4x, x minus 3, 3, x squared plus 1. Now we are going to state restrictions. X cannot be what? X cannot be 3, cannot be 1. From here, you don't get any restrictions. Okay, so yes, 3 cannot be 0. But if you try to make x squared plus 1 0, okay, so you get x squared equals -1, and it's not possible, right? So when you square any number, you will get a positive number, not you will never get a negative number. So there is no solution from here. Okay, no solution. That is the reason no restrictions coming from here. So x squared plus 1 is never a 0. Actually, it is always a positive number because x squared is always positive, and you are adding 1 to that positive number. Okay, so either you get 0 or positive, and you're adding 1 to it. So this x squared plus 1 is always positive then, and it is never 0. All right, so yeah, this is not no solution. Okay, so we have only 2 restrictions done. So this is a multiplication. We don't need to flip anything. So we can start simplifying. X squared and x squared plus 1 and x squared plus 1 is gone. X minus 3.
Wait, Miss Cass, could you show the restrictions one more time? I didn't catch it.
Yeah, 3 and 1.
Okay.
3 and 1. And no restrictions are coming from here.
Wait, what did you say?
No restrictions are coming from here.
Wait, why?
I just explained it here.
Sorry, my bad. I was not paying attention.
Yeah, so if you take x squared plus 1 and make it equal to 0, you get x squared equals -1, and this gives you no solution. When you square any number, you always get a positive number. And you will never get a negative number, okay? Because if you try to get x from here, you get plus and minus square root of -1, and that is undefined. So therefore, this one has no solution, okay? So now simplify. We are doing the simplifying. X squared plus 1, x squared plus 1 is gone. X minus 3 is gone. X minus 1 and x minus 1 is gone. Also, we have 2 and 4. Both are divisible by 2. You get 1 and 2. Okay, so then what is left for us here? So x plus 1 times 2. So 2 times x plus 1. And in the denominator, this is gone, gone, gone. Or we have only 3. Okay, somebody's mic is on.
I have a question.
Sure.
For the 2, isn't it 2x, x plus 1? The x is still left, right?
This one?
No, for the bottom one, you wrote 2x plus 1, but isn't there still the x, 2x?
2x plus 1.
No, over there, the 4x.
Yeah.
No, the bottom one. Isn't there still the x?
Which one? So
The-
this line? Okay,
No.
is it on this line?
No. Line, but you know how you simplified 4x, right? To 2.
Oh, yeah. X, this x. Yeah, sure. Yes.
Yeah.
Okay, now we got it.
Yeah, that's what I meant.
Okay. Now it is okay. Yes, x is there. All right. Okay, let's look at the last example. Again, the first thing we do is factoring. So this gives you x minus 3, x minus 2 over 2x divided by x minus 3 for x squared. Well, I guess we could directly flip this one, okay? So get rid of the division for x squared over x minus 3. Well, you know what? Let's keep the division, and I don't want to confuse you, okay? Let's do it on the second line. So first, let's factor everything. So x minus 3 for x squared times looks like 4 is a common factor. X squared minus 1 minus x minus 2 over 8 is a common factor. You get x minus 2. So this can be factored one more time. So first I do 4 times x squared minus x minus 2. Now I'm going to put here the factored form. So that is x minus 2 times x plus 1. Okay, so let's write the restrictions. We get 0 from here. So x cannot be 0. This one also 0. And this gives you 2. So x cannot be 2. Again, before you simplify anything, get rid of the division. Okay, so multiply. So 4x squared over x minus 3 times, we have 4 x minus 2 x plus 1 over 8 times x minus 2. Okay, so check restrictions one more time because we had to flip this fraction here, this rational expression. So now we have x minus 3 in the denominator. So this means that x cannot be 3. Okay, so we can start simplifying now. So x minus 3, x minus 3, x minus 2, x minus 2, 4 and 8, both are divisible by 4. You get 1 and 2. 4 and 2, both are divisible by 2. 2 and 1, 2 and 2, 1 and 1. And we also have x squared and x.
Miss Nath?
Yes.
Isn't a positive 3 gonna be a restriction?
Yeah, it is.
Oh, okay. Sorry, I couldn't see it because of the angle. My bad.
Oh, okay. Yeah, it is there. And x squared and x can be simplified. X is gone and that square is gone. X squared divided by x gives you x. Okay, so final answer. We have x minus 1. So x minus 2, sorry. You have x. So I put the x in front. And we have x plus 1. Denominator. This is gone. That is gone. This is gone. And that is gone. Everything else is gone. So we end up with this. Any question?